Volume is how much is inside. And let's be a little bit more specific, because do any of these shapes have a volume? No, why not? They're not 3D. Yeah, good. So all of these are 2D, and therefore they can't have a volume. You need them to be a 3D shape. So that's basically what we're going to be looking at. We're going to be looking at volumes of prisms, cylinders, and pyramids today. Not too bad. Is everyone good on this page, or is anyone still copying? Okay. All right, so let's start with a couple of definitions. We have prisms and cylinders. And what I want you guys to do in your notebook is I do want you to write the definition, and I want you to do your best to just do a little bit of a sketch of what these things look like. I'm sure you've seen them before. So a right prism has lateral edges that are perpendicular to the bases, with faces that are all rectangles. Now, the right prism has another name, and it's just rectangular prism. So usually with a prism, the type of prism that you have would be the shape of the base. So since the base is a rectangle, this is a rectangular prism. What is it called if you have a prism where, let me draw one out, where the base is a square? So kind of like this. If the base is a square, what is that prism called? Anyone? So this is a rectangular prism, but what's this one? Good, a cube. Okay, so we have rectangular prism, or also it can also be called a right prism. And then a cube is a type of right prism where all 6 faces are squares, not just rectangles, but squares. Then we have a right cylinder. So for a cylinder, the shape of the base is a circle. That's kind of, everything else is very similar. The only difference is that the base is a circle rather than a rectangle. Any questions on these two? I'll give you guys a few more minutes to keep writing. Pretty simple stuff so far. All right, just about 30 more seconds. Okay, moving on. Okay, and now we have 2 volume formulas. So for a rectangular prism, you guys probably already know this because it's something that you've definitely seen before. The volume is length times width times height. And for my cube over here, since all 3 sides, all 3 would have the same exact measurements, we can just use s cubed, s to the power of 3. So what I would do for today, let me see if I can actually, I know I can do it somewhere. Oh, here it is. Okay. Is maybe like on the first page of all your notes for today, we can just start a list of volume formulas. That way you have them all in the same place. So we have a prism, a rectangular prism. And then we have a cube. And I'll keep this list going as we go through today's class. I'll put it down here for now. Oh, where'd it go? There it is. Okay. Any questions on these two? Cool. All right. So let's make it a little bit more interesting. The volume of any prism is the product of the area of the base times the height. And let's just actually go back for a moment, or let me put this here. Remember that the area of a rectangle is length times width. So length times width is the area of a rectangle. So all we're really doing is we're taking the area and multiplying it times the height for a rectangular prism. Same thing with a cube, because for a cube, you could write this as S times S times S. And we know that the area of a cube is S times S, S squared. So for both of these, we're really doing area times height, area times height. So if that's the case, let me move them. What would be the formula for the volume of a cylinder? If all we need is the area of the base times the height, how would we write the formula for the volume of a cylinder? You got it, Jalen. Good. The volume of a cylinder would be the area of the base times the height. Well, the base is a circle. The base is a circle. So the area of a circle is pi r squared. Pi r squared times the height. So we can write it as pi r squared h. All right, so this is my height, and the radius is just the radius of the circle that makes the base. Any questions on volume of a cylinder? Okay, I'm gonna put it back in our, oh no, okay, hold on. The sticky note is good, but it always like, you can't get rid of the stuff underneath it, which seems kind of useless. Okay. So cylinder. Volume equals pi r squared h. And then finally, what about a triangular prism? What would be the volume for a triangular prism? Exactly, Tyrone. Yeah, you got it. You got it. Same exact situation. You have the area of the base times the height. Well, the base is just a triangle, right? So the triangle is going to have its own area and its own height. If you think of it like, this is where it gets a little bit confusing. So I just want to be very clear. This is the height of the prism. And this is the height of the triangle, of just the triangle. So we're going to be a little bit careful with this. Instead of making them both H, we can, let me see. I don't remember how your textbook does it. I think they use a different letter. Let me look it up really quickly. Okay, they call it C. Or no, oh, okay, I see it. Okay. They call, instead of making this H, they call it L. That wasn't meant to be a pun. I just kind of said it. Okay, so they call this L for length instead of calling it H for height. So it might look a little confusing, but I'll label everything so that we don't get too confused. So this is the height of just the triangle that makes up the base. And then the base of the triangle is right here. But if you just remember, we're finding the area of this triangle and then multiplying it times whatever this value is. So if all those different letters kind of trip you up, don't worry too much about it. As long as you remember to find the area of the triangle and then multiply it times the height or the length or whatever they call it. All right, so there's our cylinder and our triangular prism. Any questions on those two? Cool. Let me bring this thing back, which doesn't want to. Okay, cool. All right, cool. So those are kind of the four that we're going to start with. And then from here, we're only going to do one more after that, which is our pyramid, but that'll be at the end. So now we're ready to do a couple practice problems, starting with pretty simple ones. Pretty simple, starting with the number 2. Which formula am I using in this one? Length times width times height. It's easy. So I have 8.4 times 3.5 times 5.6. Go ahead and use your calculators and let's see what we get. Good, 164.64. What are my units? Okay, millimeters. But there's more to it, not just millimeters. Anyone know? Not squared. Squared would be area. Since this is volume, it's going to be millimeters cubed. Yeah. Cubed. And that goes for any type of units that we have. It's always going to be cubed because this is 8.4 millimeters times 3.5 millimeters times 5.6 millimeters. So we're multiplying millimeters times millimeters times millimeters. So we call it millimeters cubed. All right, and then for this guy over here, which formula am I using? Good. So 1/2 times base times height times length. Which of these is the base? 9. Which one's my height? 15. And then the length is 12. So the reason that, oh, my bad. Sorry. Come on. Sometimes, because it's like plugged in with a USB, and sometimes the USB doesn't connect very well.
12 seconds later.
Let's see.
Music cues in my head.
Come on. Nope. I don't know why it doesn't want to. Let me try a different way. Yeah, I don't know why this isn't connecting, guys. I'm sorry. Technology these days.
15 minutes later.
Oh my goodness. Okay, now do you want to work?
2 inches later.
This has never happened to me where it just like really doesn't work anymore. Let me see if I have another cord. Let me try this one.
I've grown a beard and had 2 kids already.
Okay. So rude. Okay, there we go. Okay. Where was I? So the reason that we call this L is because usually, notice like, okay, let me move this. So this triangular prism, they kind of put it down like it's standing up straight, like the triangle. If you picture this as the floor, they have the triangle down on the floor, but usually the way you're going to see it is this way. So it looks more like a tent. So it's a little bit easier to see it this way because now you can tell that, okay, this is the height, right? And then this is the base, and then this is the long side, so that's the length. But in any case, you're always just multiplying those 3 values. Okay, so did anyone get our answer while we waited? 810. What are my units? Yards. Just yards? Cubed, good. Yards cubed. So always, don't forget that you always need to end up with cubes as your units, or cubed yards. Yeah, either way. Questions? We good? Okay. Okay, let's make it a little bit more interesting. So we had a right prism and a right cylinder. You can also have an oblique prism and an oblique cylinder. And what that means is that basically it's on a slant, okay? Instead of being perpendicular to the ground, it's slanted. So you can go ahead and write these two definitions as well as try your best to do a little bit of a sketch. Yeah, it's like a leaning tower. Mm-hmm. It's the Leaning Tower of Pisa. Pisa, not pizza, Pisa.
I heard pizza.
Pisa. All right, take about a minute more. All righty, who's still writing? Anyone?
Me.
Yeah, okay, keep writing.
I'm done.
Okay. How about you, Janelle's? Done? Awesome. Okay, so let's think about these situations. So when you have an oblique prism or an oblique cylinder, what do you think is going to happen to the volume? What are some thoughts? What do you guys think is going to happen to the volume? Will the volume, would it have the same formula for volume? Would it change maybe? What do you guys think? Perla thinks the volume formula is going to change. How about somebody else? Do we agree? Do we disagree? Janelle's agrees. Tyrone agrees. Jalen disagrees. Ooh, interesting. Does anyone else disagree? The volume, so you do think the volume will change? Yeah, that's what they were saying already.
I disagree with Perla, but I'm making my own thing.
Okay, so in conclusion, you all think that the volume is going to change, right? Yes. Okay. Okay. So that's a pretty good guess because it looks like, okay, that it's kind of like if the shape leans to the side, it looks like, yeah, that's going to affect the volume. But I want everyone to picture a deck of cards, or in this case, I just have some, what are these called? Note cards. And just think about this deck of cards. It has a volume, it has a length, it has a width, and it has a height. And I'm holding it in my hand. I'm just going to push it a little bit in this direction. So now it's kind of leaning. You guys see that? So it's kind of leaning over. Did I change the amount of cards? Did I add any cards or take away any cards? No, I just pushed it over, right? So would the volume of this deck change at all? No. And so that's a really interesting property that we're going to kind of talk about now. So when you have an oblique prism or an oblique cylinder, the volume actually isn't going to change as long as it has the same radius or the same width as the original. And that is something that's called Cavalieri's principle. So it sounds kind of formal and serious, but it's basically exactly what I just showed you. And this is something that will come up. I've seen it come up as a definition question. So it's very important that you guys write this one down. Cavalieri's principle. If two solids have the same height and the same cross-sectional area at every level, then the two solids will have the same volume. So you can kind of see these examples that you have a right prism and then you have an oblique prism. You have a right cylinder and then you have an oblique cylinder. And even though one is leaning and the other one isn't, they're still going to have the same volume as each other because the height is the same and the area of the base is the same. So it doesn't change the volume at all. Just let me know when you've finished copying that down so that I know we can move on. That's okay, Perla. Just everybody let me know when they're done. All right, Tyrone is done. Janelle's is done. Anybody else still writing? All right, cool. All right, so I just included this picture just to show it a different way. If I had a deck of cards, I would have done it with a deck of cards. But basically, that's Cavalieri's principle in a nutshell. Just because something is leaning over isn't going to change the volume of it. Okay, so actually you have an interesting point, Tyrone. You're saying that it's going to get longer in this section. So the height over here, and then this is going to be longer. That's true, but the height, let me pick a good color. What's going to show up? Maybe blue? The height would be this distance right here. So the height actually stays the same because we're not going to be using the slanted side. We're going to be using the height. And you can actually see that on this slide as well. The height has to make a 90-degree angle, has to be perpendicular. Make sense? Cool. All right. So with that in mind, let's do a few practice problems, starting with the first one. So remember, the volume formula is going to be the same. We're still using the same formula because the volume is not going to change. So what would be the volume formula for this first one? What's my formula? Good. Pi r squared h. And this is the height right here. So just like what I was saying before, Tyrone, when you measure height on an oblique figure, an oblique cylinder or an oblique prism, you're going to measure this height, okay, from the top straight down to the bottom. So we would get pi times 12 squared times 45. And have your final answer in terms of pi. All right, Perla got 6,480 pi. How do we feel about that? We agree, good. That is correct. 6,480. Jalen got 648 rather than 6,480. You're missing a zero? Oh. Okay, Jalen. What are my units? Inches cubed. Cubed. Good. All right. And then finally, we have one over here that instead of just values, it's going to have a little bit of variables, a little bit of algebra. So let's see what this one looks like. First of all, what would be my formula? It's an oblique prism. Length times width times height. Good. Because again, even though it's oblique, we can still use the same formula. Length times width times height. So I have 4x times 5x times x plus 2. What should I do first here? Well, it's not really foiling because I have a monomial, and then a binomial. So which of these should I multiply? There you go, yeah. Let's do 4x times 5x. What does that give me? 20x squared. Now I can distribute that. And what do I end up with? (20x cubed plus 40). You're missing a small piece. There you go, x squared. Oh, and the units are? We still have units. If it was a 4, you would just say to the power of 4. You wouldn't say, good, Janelle's units are centimeters cubed. All right. So long story short, any questions on Cavaliere's principle? That volume is the same exact formula, regardless of if you have a right prism or an oblique prism. Cavaliere, I don't know who he was. Maybe we'll look him up. Cavaliere, I'll look him up at the end. Okay, so here's kind of more of like a test question. Sheila believes that the 2 cylinders shown in the diagram below have equal volumes. Is Sheila correct? Explain why.
If wait, I can hear myself. Never mind. I'm
can
more
hear you.
typing.
So Perla said no, and then yes. And now she's saying wait. So 11.5 is this measurement from the top to the bottom, making a right angle. The side is 12. So this length right here is 12. For this one, this is a right cylinder, so it already makes a 90-degree angle. So regardless, this is going to be the same. So what do we think? Will these two have the same volume or not? Jalen says no. Janelle says maybe yes. Okay, so I have a no and I have a yes. Tyrone says yes. So those of you who said yes, why do you think so? Why would they have the same? Why is this true? Okay, so they have the same height. What else is the same about them? The same base. Yeah. So in number 1, the height is 11.5. And what's the area of the base? What would be the area of this base? Mm-hmm. Good, 25 pi. Now on this side, the height, which of these is the height? Is it this one or is it that one? Right, it's this one. Remember that the height is always whichever measurement makes a 90-degree angle with the ground. So this is not the height. The 12 inches is not the height. It's this one. And the area of the base? Area of the base for this one? Also 25 pi. And we already know So, okay, I'm gonna write the correct long response because remember guys, on the EOC, sometimes you have to write a response and explain your answer. So let's practice that right now. Let's think of a way to explain why Sheila is correct. So we said, yes, she is correct. Why is that? Fill in the sentence. Type it in the chat. Fill in the blanks. What would be your reason? If you were going to type this on the EOC, what would you write? I'm waiting to see responses in the chat. All right, good. Thank you, Janelle's. Thank you, Tyrone. Thank you, Perla. Thank you, Emily. Good. I'm just reading your responses. That's okay, Tyrone. Good. Now, all of your responses, everybody who sent one in has a good response. It's all of them are just missing one thing. Why, like, who said that this is a true thing? Who's the person that we should probably name drop? You all wrote it down. What's his name? Cavalieri. Good. So this is something that is like in geometry, especially in geometry, there's a lot of theorems and like principles and different people's name. Pythagoras is Pythagorean theorem, Cavalieri's principle, you know? So if there's a person or some sort of name for what you're talking about, you're going to want to say it. Okay. So this would be a really good response. She is correct because according to Cavalieri's principle, and then you can say everything else that you said. So let me I'll pick on Tyrone since he put it in public. According to Cavalieri's principle, two cylinders with the same same height and base will have equal areas or equal volumes. All right, so that's kind of the most important thing is just try and remember, like I said, Cavalier's principle is really important. It comes up as a basic definition question. So if you have to answer this type of question, you definitely want to drop his name. Any questions on this? Ooh. Wow, he seems like a really mathematical kind of guy. Isn't Cavalieri a pasta? I don't know. It does sound like a pasta shape. All right, let's do another one. Go ahead and take a look at this one and answer it in the poll. All right, go ahead. All right, I have 4 answers in. I'm waiting on at least 3 more. Read them carefully and take about 30 more seconds. All right, I need way more participation than that, y'all. Come on. Get those answers in. You have 10 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. All right, so, we were actually super divided on this question. And I think I know why. So let's take a look. Let's just read these carefully. First of all, what do we know about these two? Just on what we just talked about, we know that they're going to have the same volume, right? Because it has the same amount of CDs, it's going to have the same volume. So we already know that D, or number 2, is correct. Would they also be congruent? What does it mean for something to be congruent? Very basically, what does it mean for something to be congruent? Same what, though? Equal what? Equal angles and sides. Would this have the same angles? It might have similar, the sides might be, the base and the length would be the same measurements, but we know that this is going to be longer. This is going to be longer than this one, so they don't have equal sides either. So it's actually, they're not congruent. And that's something that we have to be very careful about, because it's very easy to make that mistake. Congruent means that they have to be 100% the same. 100% the same in every way. And these are two different shapes. They might have the same volume, but they're different shapes, so they are not congruent. Okay, so, and then finally for number 3, we do have enough evidence. We know about Cavaliere's principle, so B was the correct response. So I had 2 students who chose B, but we were also divided among all the others, so got to be pretty careful with that. Questions on this one? All right. Okay, one more. Just another practice problem. Go ahead and try this one on your own. I'll give you guys about 2 minutes on this one. Or actually, you might need more than 2 minutes. I'll give you guys about 4 minutes. All right, about 1 more minute remaining. All right. 5, 4, 3, 2, and 1. All right, so for those of us who voted, because not everyone voted, and those of you who are not voting and not participating, y'all are going to hear from me later. For those of you who are paying attention and participating, here we go. D was the winning answer, but we obviously, we have people who chose every option. So let's go ahead and think about this one a little bit more. We know the volume, we know the height, we're missing the radius. So this one's a little bit more challenging. Which was the formula for this one? Pi r squared h. So I'm going to fill in everything I know and then figure out how to find what I don't know. So I know my volume. I'm going to use 3.14 for pi. I know that the height is 6. And then I have r squared. Then I need to multiply these two. So it's 3.14 times 6. Get 18.84. Good. Times r squared. To get r by itself, I'm going to have to divide by this. And when you divide, what do you get? (25.01). Then this is r squared. So you have to be careful. You have to take the square root of both sides. So we end up with 5, basically. Answer choice D. So, you're not always going to have to find the volume. Sometimes you have to find one of the other values using a little bit of algebra. So take a moment. If you did not get this question correct, make sure you write all the steps down and let me know if you have any questions. Yeah, Jalen, you forgot to take the square root. Any questions on this one? Cool. All right. So last thing, pyramids. Let's talk about pyramids for a moment. We know what they look like, but let's talk about how they're different from prisms. So take a moment and just take a look at these. We have 2 types of pyramids. I have a square pyramid. I have a triangular pyramid. And then I have a triangular prism. And I put this here because I want you guys to try to see what's the same and what's different. So what can we just shout out a couple differences that you notice or similarities that you notice? Good. The square one has more faces. That's very true. So square pyramid, how many faces does it have in total? 5. Good. The triangular ones both have triangles. Yep. So actually square pyramid also has triangles because each of the faces is also a triangle. So I'm going to start writing this down. 5 faces. How many faces does the triangular pyramid have? Including the base. Not 3, 4, yeah. Because this is a face. The one that's facing you is also a face. So 4 faces. How about this prism? 5, good. Okay, what else? A lot of triangles, right? There's triangles kind of everywhere. What other type of shape do we see that comes up? Rectangles, yeah. So our square pyramid has a square, which is a type of rectangle, on the base. And then our triangular prism has 3 rectangles within it as well. Okay, and then what is the main difference between a triangular pyramid and a triangular prism? So I just want you guys to look at these two really quickly. What is different between these two? The prism is all has triangles. Oh yeah, so 2 triangles, one at the top, one at the bottom. And what about a pyramid? Pyramid has how many? It has 1 base. Oh, okay, hold up. This is what I was hoping you would notice. How many bases does the prism have? 2 bases, top and bottom. How many bases do these triangles have? 1 base. There you go. So that's the main difference. So with a triangular prism, what happens is these 3 points, they go straight up. Straight, straight, straight up. And they make a 90-degree angle with the ground. Whereas my triangular pyramid, do they make 90-degree angles? No. But what they do is they all meet at 1 point. And so that's called the apex. And that happens for square pyramids as well. So it's not going to have 90-degree angles. They're all just going to kind of gravitate towards the same point called the apex. Okay, whereas a prism, those vertices, they go straight up, making a 90-degree angle. Questions on that? Okay, I want to get moving because I want to get to the good stuff. All right, this is just another picture. You don't need to copy it, but it's kind of helpful so that we can see what's actually going on inside of a pyramid. So if I ask you what is the height of the pyramid, we always measure the height from the apex to the center of the base, because that's what's going to give us a 90-degree angle. So the lateral height is kind of like the slanted edge of the pyramid, but the true height, the actual height, is kind of inside of the pyramid. It's from the center of the base up to the apex. That would be the height. And then the base, as always, has a length and a width. All right, so any questions on that? No? All right. So volume of a pyramid, the volume of a pyramid is given as 1/3 times the area of the base times the height. So let's actually break that down a little bit. Since I have a square pyramid, what is the area of the base? Of a square. Or yeah, we have a square here. What's the formula for the area of that base? Good, S squared. And we can also write that as length times width. So length times width times height, you can also write it as S squared height. So both of these work, but this one's the one that you're gonna probably see the most often. The length times the width times the height divided by 3, 1/3. So I'm gonna go ahead and hopefully my sticky note is still there. Awesome. And this is a square pyramid, which is what we're going to be focusing on the most. So there's all the formulas. That's all the formulas we're going to cover today. Rectangular prism, cube, cylinder, triangular prism, and then square pyramid. And while we're working on this, let's actually do this question. What would be the volume of this particular pyramid using our formula? What do we get? $3,000. 3,000 what? Oh, 3,072. Oh, Jalen. 3,072 what? Centimeters cubed. Good. All right, so that is the final formula that we're going to talk about. Now, let me just see how many slides, because we only got about 10 more minutes. Okay, let's do one quick problem and then we'll move on to one last thing we're going to do. So this one, again, pretty similar, but a little bit different. Try it out. And no, I don't think there's any more definitions, Janelle's. Just kind of problems to do. All right, I see 3 people have answered so far. I'm going to give everyone about 1 more minute. All right, 15 more seconds. I just want to make sure we get to everything. And 5, 4, 3, 2, 1. All right, not bad, not bad. We got most people choosing A. So let's take a look at this one. We just wrote down the formula. So that's V equals 1/3. And in this case, it's a square pyramid. So length times width times height. Or since it's a square, you can also write it as 1/3 S squared times height. But since it's asking for the length, we know that the length and the width are going to be the same. So the length, we can also call it S. Then I just fill in everything. So 84 equals 1/3. I know that the height is 7. And from there, I can basically try and solve this. So there's a couple of ways to do it. I don't like my fraction here, so I can just multiply both sides by 3. That cancels it out. 84 times 3, what does that give me? That gives me 252. I can divide that by 7. I get S squared equals 36. But that's S squared, and I'm just looking for S. So I'd have to take the square root of both sides. I get 6. Answer choice A. So questions on this one, questions on this type of problem where you're not looking for the volume, you know the volume, you have to search for something else. Any questions on that? All right, sounds good. Okay, let me just, okay, nope, that's not what I wanted. Oh, I thought I had it here. I'm sorry, never mind. Maybe we'll do this tomorrow, but I had a video I wanted to show you guys. No, we don't need that. These are too easy. Okay, we could do this one, but yes, to answer Janelle's question, there is a Khan Academy assignment. However, I would wait until tomorrow because there's one more volume formula that we're gonna learn tomorrow. So some of the questions on the Khan Academy, like we haven't learned it yet, but you can still try it if you want to try it tonight. Okay. So I was gonna say that at the end, but let's go ahead and just do this one. Which of the following equations could describe a square pyramid? So basically, you know that with formulas, you can write formulas a lot of different ways. So start taking a look and seeing which ones seem to be correct. Or actually, let's start with like the basic one, the one we already know. And I'm seeing it here. I just want to point something out that capital B is area of the base, whereas lowercase b is just the length of the base. So when you see it as a capital B, you know that it's talking about the area of the base. So what would be another way to write this using capital B? What is the area of the base if I have a square? Yeah, well, okay, no, yes, hold on. I'm confusing you guys. Let me erase this. Capital B, use the letter S. There you go, S squared. Okay. Yeah, and then S squared is the same thing, right? Another way to write it is length times width. So this part right here, that's B. Okay, so in order to rewrite this equation, we could just write it as 1/3 area of the base times height. So go from there. Now from here, do we notice anything that matches? Or anything we can get rid of? Get rid of D. Or just D, yeah, you're right. Wait, D or I thought you said F, sorry. D. How could you get D? What does it seem like they did? How would you get this? V over B. It's not that complicated. What did they do? They divided by B, right? Well, if you do that, cancels out. So I have V over B equals 1/3 H. Well, 1/3 H, we can write it this same exact way. V over B equals H over 3. So actually D is correct. D looks complicated, but all they really did was they divided by B on both sides. You can take F out. Yes, I agree with you. Let's look at F. So in F, what does it seem like they tried to do? They tried to get the 1/3 by itself. But in order to get 1/3 by itself, what would you have to do? Like if I wanted to get this 1/3 all alone, what would I do? Yeah, I would divide by BH. So if you wanted to write this equation, you would actually do 1/3 equals V over BH, not V times BH. So F is wrong. What about A? Because I noticed that A also has capital B in it. Does A work out? They isolated B. So on your own, isolate B and see if you get the same thing. Good, Janelle's. If you're trying to isolate B, you would multiply times 3. So I have 3V equals BH. But then to get rid of H, what would you do to it? Oh, I think the bell's about to ring. You would have to divide by H, not multiply by H. So A is also out. I think the only other answer that is correct, E was correct, and LH, yeah, and C is correct. All right, so that's kind of it for today. Tomorrow we'll kind of go over this again and do some more challenge problems. But yeah, I hope everyone has a good rest of their day. Bye, everyone. I'll put up the assignment later today. Bye.